All right, precalculus. We're going to continue this one. We are moving into logarithms, which was lesson 3.2. So this is 5 to what power gives you the answer of 1, and so 5 to the 0 power. Turns out any number to the 0 power equals 1. All right, so this next one, and remember some of us call this the circle of life. Some might have some other nicknames. So we're looking for 32 to what power gives us 2. So I know that 2 to the 5th power equals 32. I know that 32 to the 1/5 equals 2. So the answer is 1/5. So going to smaller numbers, that means we're taking roots. And so we'll have fractions there. All right, number 11. So we are going from 8 to 1/2. So a couple issues are happening here. I know that 2 cubed equals 8, which means that 8 to the 1/3 equals 2. But we have the additional issue of getting a 1/2, which is a reciprocal, which comes from a negative exponent. So our actual answer is going to be, I want the cube root of 8, but I also want that to be negative. So our final answer will be negative 1/3. All right, special property. Natural log and e are inverses. This was supposed to not be multiple choice. That's okay. So natural log and e are inverses, so they undo each other. So the answer is just 5. So there we go. We'll circle it. We'll check it. Now another reminder, the input of a log function, it cannot be 0. It cannot be negative. It always has to be greater than 0. It's not defined. We have vertical asymptotes, which will show up on other problems. So this answer does not exist. This answer does not exist. All right, also on that lesson, oh, my screen just froze. Sorry about that. Let's see if this works. Okay, another special property from your 3.2 day 1 notes. So again, the secret here is that those bases are the same. So these are inverse functions. They undo each other. So the answer is just p. So whatever's right there is the answer. This next one came up already in some of the problems that we did. So what is the relationship between a log function and an exponential function? So they are inverses. And then we get into the graphs of those log functions. So this one was a multiple choice. We're looking for a horizontal shrink of half. And so that means that there's going to be a 2 inside of the logarithm. So we'll check it and we'll circle it. Everything else was a trap. Don't pick it. We'll do a couple more quick ones and then we'll probably have to take a little break. So domain, this came up on the other problems too. So the domain of a log function, so I know that the inside has to be greater than 0. In pre-calc, we do love the interval notation, so we'll do that there. All right, so the range of a log function. So the range of a log is the domain of an exponential, which is all real numbers. So -infinity to infinity. And then since we just did those two, we can take a look at this guy right here. More domain and range. So domain is going to depend on the inside. So the initial domain was going to be greater than 0. But now I know that this inside here has to be greater than 0. So I know x has to be greater than -4. So let's switch some colors so this is easier to see. So our domain is parentheses -4 to infinity. And then just like the other problem, our range is all real numbers here. So -infinity to infinity. Maybe since we're talking about graphs, we'll keep going with some transformations. And so this guy's got a couple issues. There's a negative outside. So that is a reflection over which axis? Think about it. That's going to be the x-axis. And then we have a +1 inside. So that's going to be a horizontal shift left 1. And then still working on the graphs, asymptotes come from the insides here. So whatever number makes the inside 0 will be your vertical asymptote. So x equals 3 is the asymptote on that one. And then here's a graph which fits what we were talking about on the previous problems. So I know that an exponential growth function would do this. I know our exponential decay function would do this. Our standard log function takes the shape that you see there. So let's check it and let's circle it. And then we'll pause and we'll continue in a little bit. Thanks for watching.